Problem 2. Simplify the following logarithmic expressions. So here we will remind the few rules of the logarithms that we will be using. Logarithm of base A of the product of B and C is equal to what, Ivan?
Is equal to logarithm A of B plus logarithm A of C.
Mm-hmm. So this is the product rule. And another one we have here, if I have B to the power of C, I can simplify it and I will have?
C times log A to the B.
Log A of B. All right. And one more rule here. If I want to switch the base and the argument, I need to take the reciprocal. So if I have log base A of B, but I want to switch it and I want B to be my base, I will need to take a reciprocal and I will write log now base B of A. All right, now we'll do the examples here. Let's look at the first one. We have log base 2, both of them. And actually, we also didn't write the quotient rule. We could have used that one as well. We will do it two ways. We can do it by splitting, or we can also do the quotient rule here. So let's remind that B over C. It's kind of like the product rule, but now we have the minus log base A of B minus log A of C. So if we look at the first one, we can notice that they have the same base, and maybe we can use this last rule that I wrote, or we can also work with 80 because maybe we can split it into something more convenient. So
what I noticed is that 80 is splittable into 16 and 5.
16 and 5. Very good. So for 16 times 5, we can use this first rule. Let's use it.
So we'll have log 2 of 16 plus log 2 of 5.
And plus, and it conveniently cancels with
log
minus log.
Yeah. So then we just have log 2 of 16. 2 to the 4th is 16, therefore log 2 of 16 is 4.
So 16 is 2 to the 4th. Log asks my base, which is 2, into what power is equal to the argument, which is 2 to the 4th. So this is 4. We did it by splitting 80 into 16 times 5. Let's now do the quotient formula in reverse. Notice we have this. Let's use it. Let's change it into that.
So if we have these and they both have the same base, then we can just do log 2 of 80 over 5, which conveniently is 16, which is the same thing as we have.
Yes, so we combine them, 80 over 5, and then we get exactly the same thing. All right, very good. So this is part A. Then in part B, we have this 2 into the exponent, and we have the logarithm in the exponent. You might remember that logarithms and exponents, like inverses of each other, they cancel the action of each other. They do opposite. So here, if we talk about it intuitively, 2 into the power of what? The logarithm asks 2 into what power is equal to 17? And now we are raising 2 in that power. So what will we get?
So since it's asking, the answer to log 2 of 17 is going to be the power you need to raise 2 to get 17. Therefore, the answer is going to be 17.
That's right. So it's kind of these two canceled each other, and we're getting just 17. Or conceptually, like we just explained. Good. So that's part B. Next one is part C. And here, the bases are not the same. And I already erased this formula. Do you remember what it was that we will need to use here? Because the bases are not the same and we cannot work with them as they are. When we swapped the base and the argument.
Yeah, you'd need the reciprocal.
We want the reciprocal. It's 1 over, and now we swap them. The argument becomes the base, and the base becomes the argument. Let's do it here.
So we're going to do it for log 2, yeah? Therefore, when we flip it, we're going to have 1 over 5, log 5 at 2.
Log 5 of 2. Very good. Now we have the same bases. That's nice. Let's work with log base 5 of 8. Any ideas?
So since they have the same base, then we could do the other formula that you showed us for A and B.
We cannot do the formula for the quotient because if you have log A over B, then it will be the difference of them, right?
Yeah.
B. So it's not really that, because here we have 1 whole log over 1 whole log in the denominator. What else can we do? Let's notice 8 in here, because 8 is...
That's 8. Oh, yeah, I know. So basically you have log 5 to the 8 over log 5 to the 2. And 8 is 2 cubed.
Very good. 8 is 2 cubed. So let me rewrite it with that understanding. So our expression will be log base 5 of 2 cubed, which is 8, over log base 5 of 2. Very good.
But we also have the rule, which gives us the fact that log base 5 of 2 cubed is the same thing as 3 times log 5 over 2.
We can bring the exponent in front, because we know that log base A of B to the C, that exponent goes to the front, and we have log base A of B. So that's exactly what we will do here. Let me write it. It will be 3 times log 5 of 2 over log 5 of 2. All right, and finally?
Then we have the log 5 of 2 cancels out, and we'll just have 3.
And then 3 will be our final answer. All right.